that time going on. So, she's shown up, and for the next sort of 15, 20 minutes, we're going to have a little chat. And I would like you just to quickly introduce yourself, and then we're going to get into the guts of this. But could you just, for the audience, you're going to do it much better than me, just talk about yourself and what you're doing, Miranda, please.
Sure, yeah. Thank you, James. Hi, everyone. My name is Miranda Wang. I'm co-founder and CEO at Novoloop. We are a chemical upcycling startup based in Menlo Park, California. And we focus on taking plastics that are hard to recycle today and using new chemical innovation to transform it into high-value performance materials. So I've been working in the plastics recycling space, plastic waste solution space for over 15 years of my life. I've been living and breathing this problem for a long time. And since founding Novoloop 8 years ago, have been really focusing on the technology aspect of the problem. And we're currently at the point where we're at the stage right before building our first commercial facility. And so we're building out, we've been developing the technology over the past 8 years, and now we're working on completing the commercial planning for the first industrial facility. And we'll soon be going out to fundraise the capital needed to build this into an actual commercial factory. And so that's a little bit about me. I've had a long personal history with this issue.
And how do you feel about the space? Because you have deep knowledge, you have a scientific background, you're creating something which is hugely ambitious, I imagine, to build an industrial facility. And when we were talking, we were thinking about some of the pros and cons and what's going on in the plastic space at this stage, because it's been an issue. It's been an issue for many, many years.
Yep.
And it's kind of, you still go and it's like, what's really happening? It sort of feels like we're around the edges. What are just sort of lay out the scenario that as you see it?
Yeah, I think Svanika did a great job kind of laying the landscape here with the problem. On a high level, we as a society are producing over 300 million metric tons, that's 300 billion kilograms of fossil-based virgin plastics every year. And a lot of this material is not just packaging, it's going into performance goods too, like your cars, your shoes, a lot of things you depend on, the chairs you're sitting in. And the issue is that since we've had plastics, 50 to 70 years ago, it's come into mass commercialization, we have not been keeping up with finding ways to make use of this material at the end of its life. Recycling has been around for a really long time, but the issue is that so far recycling is able to address less than 9% of that material every year. So if you look at specific categories, like you saw in the video from Repurpose Global, a lot of the plastics that are discarded in the landfills are the lowest value plastics. So things like, not a whole bunch of things like water bottles, because PET water bottles are actually relatively more valuable than things like trash bags. You see a whole lot of these lower value materials, and they are really hard to recycle. They're hard to recycle for a couple of reasons. First, they lose their structural integrity when they're put into a mechanical system where they're shredded, washed, and remelted. You can't really make very good products out of that. Second is that the cost of doing it is so high that it's really hard to compete with a lower performing material at the price of virgin fossil-based plastics. You're essentially competing at a price premium with the worst products. And so these are some of the reasons why it's so hard to recycle, because plastic as a material wasn't really invented to be able to be recycled very easily. But we are in this issue now where we're so dependent on it, we have such large volumes of it, it's just not okay to be able to essentially continue in this linear economy model. And so what we have been working on Novoloop, my perspective on this has always been, instead of extracting the fossil fuels, digging deeper and deeper for that fresh carbon resource, we have over 8 billion tons of plastic on the surface of this planet. All the plastics we ever made are virtually still with us because they don't rot. Plastics don't rot. They're not like compost. And so if we can find new ways to unlock the structural components in the plastics, the carbon molecules in there, and really make brand new quality goods and do so in a profitable, competitive fashion with fossil-based processes, then we can actually enable true circularity. And those are the technologies that are missing right now. And those inventions, a lot of them don't exist. So, in the landscape of what's out there, we have a lot of talk about mechanical recycling, but that is a space that's hit a lot of maximums. And a lot of the work that's being done is helpful to try to recover as much as you can, but we need to go beyond mechanical recycling. Compostable materials are obviously a very promising new space. It makes a lot of sense for things like food packaging, but composting something means it turns into CO2. So think about it, that's linear. Going from fossil-based, a lot of compostable plastics are still made from fossil-based molecules, or maybe they're made from food sources, or things that can compete with food sources. And then we turn them to compostables, and then they end up becoming CO2. So that's not a perfect circular solution. A circular solution has to go from plastic waste back into new quality plastics, and then go around that circle over and over again. And we don't have technologies that can do that.
And thank you for, that's a comprehensive and slightly depressing, but in terms of what you're doing at Novoloop, you're doing R&D to try and find those technologies? Are you're kind of, and how confident are you, and how is what's the appetite for investors to help?
Yeah, so at Novoloop, we've invented one of these technologies. Yep. So since I started working on looking at the plastic problem a little bit deeper, it became evident that if you really want to solve the 91% of the problem plastics, it's not going to be on perfecting a little bit more on the sortation technologies or the wash technologies or the mechanical technologies. That's not enough. You're not going to be able to dig into the 91% in a substantive way. To be able to do that, you have to create new methods to make use of those molecules in the hard-to-recycle plastics. And so that lies in chemistry. Plastics are made by chemists. This is a material that is actually built with organic molecules. So it's very interesting. Plastic as a category is a technical material like glass or metal, but is built with organic molecules, just like food waste and compost and bioproducts, right? And so we have been looking at plastics solely as a technical material and thinking about cycling it as we do with metals and glass. But it doesn't work quite well enough that way. In my opinion, that is one of the biggest limiting factors of why we have not been able to go further on thinking about, plastic to X. What can you make with plastic waste? And the solutions lie in the molecules and the chemistry of it. If you can break apart the molecules inside the plastic waste, purify it, and restructure those molecules and resynthesize them in a way such that you get brand new performance, you get high value from that material, then you're changing the game on what's possible to be created from plastic waste. And so what we do at Novoloop is we invented a new chemical process that essentially, when it's scaled up, becomes a new value chain. So we start with polyethylene waste. Polyethylene is things like trash bags, pallet wrap, shrink wrap, a lot of that food packaging in the thin film form that you use and throw away. There's just really very little recycling for that. And so we take that material, and that material is really hard, even chemically, to break apart. Because it's a really long linear chain of carbons. And so carbon bonds have a lot of energy embedded in them, and to break them apart, you traditionally have to put a lot of energy. And so what we do here is, instead of some approaches that big chemical oil companies are doing, which is they're trying to turn that plastic back into oil by putting it into a really hot reactor in vacuum of oxygen, and they're just trying to pyrolyze it into oil, and then they're taking that oil and trying to put into a refinery and keep the refineries up. The issue with that technology is that you actually cannot achieve 100% recovery rate on those molecules. A lot of those molecules are going to have all sorts of problems, like cross-linkages, so you can't really make use of a lot of that. You still end up having to use a lot of virgin fossil fuels to be able to keep that process up. So we thought, what if we went a different approach? What if instead of making oil, we break apart that linear chain of carbons into shorter chains, these small chemical base units, or building blocks, if you will, and use them to build into a higher value material, something inherently higher value than the thing we started with. You start with a trash bag, and then you make something as a polyurethane, right? So that's an example of our first product, a thermoplastic polyurethane. And that's a material that can be used over and over again, many years. It's an elastic material that's highly abrasion resistant. You can use it to build shoes and cars and use it for many years. That's something that's worth 30 to 50 times more just in natural value. And today, we are not even able to make that from anything that originates from waste, right? So that is the power of being able to think about and essentially rebuild materials on a chemical level.
Which is an extraordinary, it's extraordinary to be able to do that, as you say, and transformational to this whole debate. Tell us about your partnership with On Shoes. Bring it to life, because I think you've got a partnership, and they're using performance materials in some of their shoes, right?
Right,
How's that, and explain how that works.
Yeah, so we've been focusing at Novoloop on not only the process development, which is this core technology that we've created that decomposes the polyethylenes to make the chemical building blocks. And then from there, we synthesize them into a much higher, innately higher performing, higher value products. It's called a thermoplastic polyurethane. And TPU is used in a lot of consumer applications. So things that you're using every day, even your cables. Say when you're wearing headphones, your cable, the white cable liners. If you have an Apple product, it's in consumer electronics, it's in cars. Even if you sit in a car, the lumbar support inside the car, it's got an air bladder. That film layer is made with TPU. If you're wearing a waterproof jacket, the adhesives and the seams are made of TPU. So this is a product that is like in everyone's lives, and 99% of the market of that product is all coming from fossil-based because it's so high performing that companies are not able to buy something lower performing from mechanical recycling. So, we have been addressing specifically the application space for this material in footwear. And last year, we showcased a shoe with On, a Swiss athletic brand On, and the shoe is called Cloud Prime.
Yep.
And we contributed to the world's first chemically upcycled TPU outsole on the shoe. And what was remarkable about this is that not only was this outsole material chemically made from plastic waste that was hard to recycle normally, but also that material was able to pass laboratory and athlete on-foot testing with comparable performance to the virgin quality TPUs that are made today by large commercial suppliers directly from fossil fuel. We have been able to reach performance parity, and in some cases, abrasion and wear resistance, even better performance. There was more traction, for example, when the athlete noted that the shoe was even a little bit better on grip on wet surfaces. So that's remarkable, because usually when you talk about recycling, you make crappier products, and you have to compete on the price. But when you change that aspect, and you can make similar performing or even better performing products, and offer it at a carbon reduction, so we have an up to 41% lower CO2 footprint in our final product compared to the fossil equivalent, as well as price parity. So this whole thing is the process we have allows us to be at price parity with the fossil-based equivalent. So that means to the customers, to the brands, when they're looking at sourcing, they're not choosing between sustainability and their bottom line. And we have known for a long time now that if you make companies choose between those two things, sustainability is going to have to lose. So when you remove the economic decision factor away from this, purely the sustainability is essentially the reason for the switching cost. And I really believe that this is what it takes to be able to get more of the economy buying into circular products.
I mean, amazing. I think that's worth a round of applause because that you are proving, you're proving that this is so difficult to do, and you're proving that not only can you do it, but you can better performance, less CO2, and and brands and same price. And I think the amount of times it's like it's more expensive, can't do it, as you say. Sustainability, unfortunately, is difficult if it's not the same price. So some of the conversation we were having earlier about some of the brands saying, it needs to be at the same price, and you're a proof point of this. So we've got very little time left, Miranda, but just give us a perspective in the kind of you're in West Coast of the United States. is there an appetite for all of this? Is there how you feel? You know, the investment community. You know, is this going to be a thing, or is it kind of tough at the beginning? I mean, you've got this great relationship with a Swiss company, so you had to come all the way over here to find someone to partner with for that. But how's it feel on this journey?
Well, I have to just first throw out that I think, from my experiences in business, a lot of Swiss companies have been some of the most innovative and most forward-looking. So just to call out, you know, On has been a remarkable partner for us to work with. Rolex, for example, supported us when we were at an early technology development stage and awarded us with the with a Awards of Enterprise grant. So I have a lot of good things to say about them. But from the other side of just investors in the U.S., you know, over the past couple of years, there's been a huge amount of growth going into climate technologies. The challenge is there are gaps in the funding. It's not like software where you can have these seamless transitions as you go through the different phases of growth as a company. In the space we are in, when you're dealing with first deep tech, you are in pre-revenue stages for a long time. That's a world that they're not used to. If you're in software, you want to see organic revenue growth. You want to see being able to grow that when you inject new capital. But if you are building something like ours, where essentially you're selling materials, but if you don't have a plant, you cannot sell materials and generate commercial level revenues, right? These are unfamiliar territories for investors. And they're learning, they're trying to learn how to digest and understand and mount this risk curve. The challenge right now also in the global economic landscape is the high cost of capital. And I think this is going to significantly make it harder for companies that are building first of its kind commercial scale-ups to be able to access the capital they need. I mean, we're talking about in private equity expectations, 20-25% IRR unlevered, you know, and based if you do project financing, 15% easy on annual interest rates, right? This is very high cost compared to what we've seen before. And that means your project needs to not just be good, you need to convince the investors that there's low risk enough that you can generate those returns as soon as, you know, the plan is up and you can hit the ground running. So there's very little room for error. And that's very challenging. But with all that being said, there is appetite for this. There are mandates for how the money has to be invested. And at the end of the day, it comes down to the strongest projects.
So I think that's a very good just snapshot of you know, some of the challenges, but also some of the opportunity. And unfortunately, we now have to draw this to a close. But Miranda, I would back you. You know, I think you are a force of nature. I think this lady will make this happen. I can see the nodding in the audience. I think she's absolutely incredible. And, you know, again, thank you so much for coming to ChangeNOW on behalf of ChangeNOW. Thank you to On for supporting you. Thank you to Rolex for supporting you. And thank you to the audience for being here today.